This is the Quizizz 8th grade SBAC review, part 1. In problem 1, we need to convert to scientific notation. So currently this number is in standard notation. And to convert it to scientific notation, we need to increase the value. Right now, it has a very small value. So we're going to move the decimal 1, 2, 3, 4, 5 place values. And we stop here because in scientific notation, this term has to be greater than or equal to 1, but less than 10. So we stop here and we get 7 and 1300ths. 7 is greater than or equal to 1, but less than 10. And since we increased this value by 5 place values, which we're multiplying it by 10 5 times, we have to decrease it, so it's a 10 to the negative 5th power. In problem 2, convert to scientific notation. Well, now we have a number that has a very big value. So what we're going to do when we convert it to scientific notation, we're going to decrease the value. So we're decreasing it by 1, 2, 3, 4, 5, 6 place values. And again, we stop here because now we have 2, and 2 is greater than or equal to 1, but less than 10. So we couldn't stop here because that would be 23. And since we decreased it by 6 place values, the exponent has to be increased by 6 place values, so 10 to the 6th power. Number 3, we have 5 to the 3rd power raised to the 4th power. And remember, when you have a power raised to a power, the rule is that you multiply. And I always put a little slash here because then that gives me the multiplication symbol and it reminds me, yes, I need to multiply these exponents. So we have 5 to the 3rd multiplied by 4. 3 multiplied by 4 is 12. And I'm going to leave it as an exponent form. If this was 4 or less, then I would simplify it. But since it's 5 to the 12th power, I'll leave it in this form. Another way you could see this problem and simplify it is you have 4 groups of 5 to the 3rd power. So 5 to the 3rd, 1, 2, 3, 4 times. And the rule for multiplying integer exponents with the same base is you add the exponents. So 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. So we still get 5 to the 12th power. For number 4, we need to evaluate the cube root of 64. Before I do that, I want to look at the square root of 64. What number multiplied by itself 2 times would give you 64? That would be 8, because 8 multiplied by 8 is 64. But in the cube root of 64, you have this 3 here next to the radical sign. It's telling you what number multiplied by itself 3 times would give you 64. Well, that would be 4, because 4 multiplied by 4 is 16, multiplied by 4 is 64. So the cube root of 64 is 4. For number 5, we need to simplify 8 to the 2nd power divided by 8 to the 5th power. Remember, the rule for dividing integer exponents with the same base is that you keep the base and you subtract the exponents. So I always remind myself that this fraction bar reminds me of a subtraction sign. So here I have 8 is the base, 8 to the 2nd power, so 2 minus 5. So 2 minus 5. And I have more negatives and positives, so I know it's going to be a negative. So 2 minus 5 equals negative 3. And when you have a negative exponent, you have to take the reciprocal. So it's going to go down to the denominator. So now we have 8 to the third, which is 8 multiplied by 8 multiplied by 8. So 8 multiplied by 8 is 64, multiplied by 8 is 512. Another way to solve this is 8 to the second power is 8 multiplied by 8, and 8 to the fifth power is 8 multiplied by 8 5 times. Here we have big ones. 8 divided by 8 is 1, 8 divided by 8 is 1, and now I put a 1 here multiplied by 1 because you can't just have nothing up here, because 8 multiplied by 8 is 64, multiplied by 1 is still 64, so I'm not changing the value of this. So now I'm left with 1, and then 8 multiplied by 8 multiplied by 8 is 8 to the third. For number 6, I need to simplify 7 to the negative second power. And remember, you can't have a negative exponent, so you'll have to take the reciprocal of that, which brings it down from the numerator down to the denominator. So 1 over 7 to the second power. 7 squared is 7 multiplied by 7, which equals 1 over 49. For number 7, I need to simplify this expression. So I have 5x to the third multiplied by 2x squared. Well, I'm going to multiply these two terms together, but I can only multiply like terms. So I have 5 and 2, which are integers, and x to the third and x to the second. So 5 multiplied by 2, and x to the third multiplied by x to the second. 5 multiplied by 2 is 10, and remember, when you're multiplying integer exponents with the same base, you add the exponents. So 3 plus 2, which is 5, so 10x to the fifth. For number 8, we need to convert to a fraction. So here we have 0 and 25 hundredths repeating. So the 25 will repeat forever. So I'm going to start out by saying, let's let x equal 0 and 25 hundredths repeating. So next I'm going to take that number and multiply it by 100. So I'm multiplying both sides of this equation by 100. 100 multiplied by x, and then 100 multiplied by 25 hundredths repeating. When I multiply 100x, so that's, I get 100x. When I multiply 100 by 25 hundredths repeating, that 100 moves the decimal to the right. I'm increasing the value by 2 place values. So now I have 100x equals 25 and 25 hundredths repeating. So now what I'm going to do, I'm going to subtract x from both sides. And remember, we said x equals 25 hundredths repeating. So I'm going to subtract x from this side, and I get 99x. And I'm going to subtract 25 hundredths, which is x, 25 hundredths repeating, from this side. And you can see that the 25 hundredths repeating is all going to eliminate all the way, because 25 hundredths forever, 25 hundredths forever, so they're going to cancel each other out. And I'm left with just 25. And so now I have 99x equals 25. Divide both sides by 99. This creates the big 1. And now I have x equals 25 99ths. Here we have 5 repeating, or 5/10ths repeating, and that would look like this, 5/10ths repeating. So I have one place value that is repeating. So it's 5 over 9. So if I have one place value repeating, there's 1 9. Here I have 37 hundredths repeating, and that could also look like this, 37 hundredths repeating. Well, now I have 2 place values repeating, and you can see that I have 2 9s. Here I have 125 thousandths repeating, 1, 2, 3 place values, and 1, 2, 3 9s. So however many place values are repeating is how many 9s you're going to put in the denominator. If this had 4 place values repeating, I'd have 4 9s. If it had 6 place values repeating, I'd have 6 9s in the denominator. For number 9, we need to determine which best describes an irrational number. Well, first I wanted to define what a rational number is. And if you look at the word rational, you see the word ratio, which means fraction. So any number that can be written as a fraction or a ratio would be a rational number. For example, 1, 2, 3, 4 natural numbers can all be written as a fraction. 1 over 1, 2 over 1, 3 over 1. Those are all fractions. Whole numbers include all the natural numbers, and 0. 0 could be 0 over 1, which is 0. So that could be written as a fraction. Integers are whole numbers and their opposites. Negative 1 over 1 is still negative 1, and that is a fraction. So here are examples of rational numbers. 2, negative 2, 1/2, negative 1/2. These are all can be written as fractions. And then any perfect square, like the square root of 49, which is 7, can be written as a fraction, 7 over 1. So perfect squares, remember, square root of 100 is 10, square root of 81 is 9. All perfect squares are rational numbers. Irrational numbers are numbers that cannot be written as a fraction. So, for example, any non-perfect square is irrational. There's no number that you can multiply by itself that will get the square root of 48 or the square root of 71. These are not perfect squares. So all non-perfect squares are irrational. Any number that any number that goes on that does not terminate or does not repeat is an irrational number. For example, the most famous irrational number is pi. Pi goes on forever without repeating or terminating. For number 10, the square root of 25 is 5, because 5 multiplied by 5 equals 25. And this is also, remember, a rational number, because it's a perfect square. Square root of 37 is irrational because it is not a perfect square. There's no number that you can multiply by itself that will equal 37.